Maui, Hawaii. The 8th of August, 1944. On the dusty slopes of Mount Haleakala, a firestorm erupted that would reshape Pacific warfare forever. The thermometer stopped at 2,198 degrees Fahrenheit as napalm engulfed reinforced concrete, melting steel and incinerating everything within. The weapon that engineers had called impossible to deploy just 9 months earlier was now reality. Built by civilian scientists, deployed by farm boys from Kansas and steelworkers from Pittsburgh, it would end the strategic stalemate that had consumed thousands of American lives. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed because tomorrow I've saved something extra special for you. In the war room at Pearl Harbor, maps covered walls showing Japanese island fortifications. Red pins marked underground bunker networks where conventional bombing had proven ineffective. Captain James Lawrence studied damage assessment photographs, concern etched across his face. These underground systems remain operational after 800 tons of conventional ordnance, he noted to the assembled staff. The concrete withstands direct hits. We're using entire bombing runs and gaining nothing. The strategic problem was undeniable. Japanese defenders had constructed networks of reinforced bunkers with walls 2 meters thick. Conventional bombs created surface damage but left the networks intact. Defenders emerged minutes after raids to remount their guns. The casualty projections for infantry assaults against these positions were staggering. Marine Corps planning officers estimated 65% casualties for frontal assaults against Iwo Jima's bunker network, potentially 35,000 American dead. Something had to change. In the basement laboratories at Harvard University, chemistry professor Louis Fieser reviewed thermal conductivity equations. His specialty was organic compounds and their reactions with oxygen. Before the war, his research focused on cancer treatments and synthetic quinones. Now it focused on ways to overcome reinforced concrete at temperatures previously thought impossible outside industrial furnaces. Fieser's team worked with an unusual substance, a mixture of petroleum distillates and thickening agents that adhered to surfaces while burning. The military designation was fire gel, but they called it Harvard Punch. Initial tests showed temperatures reaching 800 degrees, impressive, but not enough to penetrate bunkers. "We need a quantum leap," Fieser told his research team, "not incremental improvements." Across the Pacific, Japanese Colonel Tadamichi Kuribayashi supervised construction on Iwo Jima. Workers poured the last concrete into Bunker 703, the centerpiece of the Northern Defense Network. The walls were 4 meters thick, reinforced with salvaged ship steel. Ventilation systems included chemical filters. Food and ammunition stocks would last 3 months. His engineers had assured him the structure could withstand anything short of a direct nuclear strike. American bombers waste their payloads, Kuribayashi told his staff. Their conventional weapons cannot penetrate our defenses. Each failed bombing run increases my men's confidence. Intelligence reports indicated American casualties in the Pacific had reached 67,000. The bunker strategy was working. Japanese military doctrine emphasized defense in depth, trading space for time, bleeding American forces through attrition. In Washington, D.C., War Department officials reviewed the strategic projections. Admiral Chester Nimitz had requested a review of all chemical and incendiary research programs that might offer solutions. The meeting minutes noted, "Conventional approaches have proven inadequate against hardened defenses. Novel solutions required before planned amphibious operations in 1945. The chemical research team at Standard Oil's New Jersey laboratories joined the effort. Their petroleum engineers understood combustion chemistry better than anyone. Research director Robert Adams combined his petroleum knowledge with Harvard's chemical expertise. "The problem isn't just creating heat," Adams explained. "It's creating heat that sticks and penetrates. We need something that flows into ventilation ducts, something that carries its own oxygen supply." The breakthrough came unexpectedly. A laboratory accident in Cambridge revealed that certain metallic compounds, when added to the gel, created an exothermic reaction hot enough to melt laboratory equipment. The temperature gauge read 1,800 degrees before it failed. When they tested the mixture on concrete samples, it didn't just damage the surface, it penetrated, following cracks and expanding them, carrying destructive heat deep into the material. Military observers were skeptical. Captain William Harrison from Army Ordnance witnessed a demonstration and noted, "The effect on test materials is impressive, but delivery remains problematic. How do you transport something this volatile? How do you target it precisely? This remains a laboratory curiosity unless those questions are answered." At California's Camp Pendleton, Marine Corps equipment specialists confronted the delivery problem. Standard aircraft bombs wouldn't work, they dispersed on impact, wasting the precious gel. The solution came from an unlikely source, 2LFO, fuel tank design. Engineers created compartmentalized canisters that ruptured on impact, dispersing the mixture in a controlled pattern across target areas. The M47 incendiary bomb was born, 100 pounds of jellied fire. Preparing and narrating this story took us a lot of time, so if you are enjoying it, subscribe to our channel, it means a lot to us. Now back to the story. Test results from the Aberdeen Proving Grounds showed startling effectiveness. The new weapon penetrated 30 inches of reinforced concrete, creating temperatures that sustained above 1,900 degrees for nearly 5 minutes, long enough to ignite anything inside the structure and compromise structural integrity. The report concluded, "Material demonstrates unprecedented penetration capabilities against hardened targets. Recommend immediate field deployment." A demonstration for military leadership at Dugway Proving Ground used a replica Japanese bunker built to exact specifications from intelligence reports. Photographers and film crews documented the test from safe observation bunkers. A single B-29 dropped 6 canisters on the target. What happened next silenced even the most skeptical officers. The concrete didn't just burn, it cracked, spalled, and in sections, actually melted. Internal temperatures exceeded 2,000 degrees. General Curtis LeMay reviewed the footage 3 times. "This changes our strategic approach entirely," he noted. "The question is no longer whether we can neutralize these fortifications, but how quickly we can deploy this capability across the Pacific Theater." Production orders went out immediately. Chemical plants in New Jersey, Pennsylvania, and Michigan converted from synthetic rubber production to manufacturing what was now officially designated napalm. Production challenges emerged immediately. The stabilizers required careful handling. Minor formulation errors created batches too unstable for field use. Quality control became paramount. Dorothy Hoffman, a chemical engineer who had worked on synthetic rubber before the war, established testing protocols that maintained consistency. Each batch must meet exact specifications, she instructed production supervisors. Lives depend on formulation precision. By December 1944, production reached 500 tons per month. Still insufficient for theater-wide operations, but enough for targeted deployment. Strategic Air Command planners identified priority targets, IMCAI, command bunkers, ammunition depots, and fortifications surrounding critical airfields. The first combat deployment would target Iwo Jima's northern defense network as a proving ground before the main invasion. Training bomber crews required new precision techniques. The canisters needed to be delivered with accuracy, impossible with conventional bombing. Major David Hamilton developed a low-altitude approach that increased accuracy but exposed aircraft to significantly more anti-aircraft fire. "We'll take the risk," Hamilton told his squadron. "The alternative is thousands of Marines dying on those beaches." The weapon remained classified at the highest level. Security around the program was absolute. Production facilities operated under cover stories. Shipping containers carried misleading labels. Even the bomber crews were told only that they were carrying special ordnance. The tactical surprise would be complete. On the 3rd of February 1945, 15 days before the scheduled Marine landing on Iwo Jima, the first operational mission deployed. 24 B-29 superfortresses from the 21st Bomber Command carried 900 napalm canisters targeting the northern bunker network. Colonel Kuribayashi's men tracked the approaching formation with confidence. Previous bombing runs had proven ineffective. Their bunkers would protect them as they had dozens of times before. What happened next shocked even the American observers. The napalm canisters ruptured precisely as designed, spreading across bunker entrances, flowing through ventilation systems, and penetrating gun emplacements. The temperature spike was immediate and catastrophic. Concrete that had withstood months of conventional bombing began to crack. Steel reinforcements warped. Underground tunnels became infernos as the burning gel penetrated deep into the complex. Reconnaissance photographs taken 3 hours after the raid showed what conventional bombing had never achieved: iron, collapsed bunker roofs, sealed entrances, and destroyed gun positions. 7 key defensive positions had been neutralized in a single raid. The post-strike assessment was clear. Target area shows catastrophic, defensive degradation. Effect on underground facilities exceeded all projections. The impact on Japanese defenders was psychological as well as physical. Survivors reported an unprecedented phenomenon, ASO. Defenses they had considered impregnable were suddenly vulnerable. The certainty that had sustained morale through months of bombing evaporated in a single morning. Lieutenant Hiro Tanaka's diary, recovered after the battle, recorded, "The Americans have unleashed hell itself. The concrete burns. How do you fight when the earth burns?" Admiral Nimitz received the preliminary battle damage assessment with cautious optimism. "If these results are verified, we've changed the equation," he told his staff. "Every island fortress in the Japanese defense perimeter suddenly becomes vulnerable." The strategic implications were enormous. Operation plans that had projected campaigns lasting into 1946 were cautiously revised. The production demands intensified. General LeMay requested 10,000 tons monthly, a 20-fold increase. American industry responded with characteristic efficiency. Chemical plants operated around the clock. Rail cars delivered raw materials continuously. Storage facilities expanded. What had been a specialized weapon became a standard ordnance item in breathtaking time. On the factory floor at Standard Oil's converted Linden plant, 3 shifts of workers maintained production. Many were women who had never worked in industry before the war. Production supervisor Eleanor Martinez maintained quality control with relentless precision. "Each canister we produce saves American lives," she reminded her teams during shift changes. "Precision isn't just about specifications, it's about bringing our boys home." Testing continued at an accelerated pace. Engineers discovered that adjusting the gel's viscosity created different effects, ATA. Thinner mixtures penetrated deeper into structures, while thicker formulations adhered to vertical surfaces longer. Both had tactical applications. The weapon was evolving from a specialized tool to a versatile system that could be customized for specific targets. Bomber crews developed specialized tactics. Captain Richard Davis pioneered the ripple drop technique, staggered release patterns that created overlapping coverage of target areas. His approach increased effective coverage by 40% while using the same amount of ordnance. "We're not just dropping bombs," Davis instructed his squadron. "We're placing a precision tool exactly where it needs to be." On Iwo Jima, Colonel Kuribayashi faced a strategic crisis. His northern defenses, the cornerstone of his defensive plan, had been compromised more severely than initially assessed. Emergency repairs proved futile. The napalm had caused structural damage that couldn't be addressed with available resources. He ordered his reserves to reinforce the southern sectors, abandoning the northern approach he had previously considered impregnable. American intelligence intercepted communication traffic indicating the disruption. Planners adjusted the marine landing zones accordingly, shifting emphasis to exploit the newly created vulnerability. The operational advantage was clear and immediate. Colonel Robert Williams of Marine Intelligence estimated, "This weapon has potentially saved thousands of American lives before the first boot hits the beach." The success triggered an immediate review of strategic bombing priorities across the Pacific theater. Targets previously considered impractical due to their hardened defenses were reconsidered. Islands that might have required months of preliminary bombardment could now potentially be neutralized in days. The timetable for the advance toward Japan itself accelerated. In the laboratories, work continued on refinements. The original formula, devastating as it was, represented just the beginning of possibilities. Chemical engineers discovered that adding certain metal salts increased burn temperatures by another 200 degrees. Penetration compounds improved flow characteristics through narrow openings. Each modification made the weapon more effective against specific target types. The Japanese High Command received reports from Iwo Jima with growing alarm. Their entire defensive strategy across the Pacific had been built around hardened fortifications. If those fortifications were suddenly vulnerable, everything changed. Emergency directives ordered deeper burial of critical facilities, but the logistics were impossible on most islands. There wasn't enough time, equipment, or concrete to adapt. By mid-February, napalm production reached 2,000 tons weekly. Distribution logistics became the limiting factor rather than production capacity. Transport ships carried special storage compartments. Handling protocols became more sophisticated. What had been an experimental weapon had become a central element of American strategy in less than 6 months. The transformation was more than technical, it was psychological. American forces advancing across the Pacific carried a new confidence. The fortifications that had exacted such a terrible cost at Peleliu and Tarawa no longer seemed invincible. Japanese defenders, conversely, lost the certainty that had sustained their resistance. The balance had shifted fundamentally. On the 19th of February, 1945, Marines landed on Iwo Jima. They encountered fierce resistance, but nothing like the impenetrable defense that had been projected without napalm's intervention. The northern sector, which military planners had estimated would require a week of fighting with thousands of casualties, was secured in 19 hours. Post-operation analysis confirmed what the preliminary reports had suggested. In Zio, the pre-invasion napalm bombardment had been decisive. In his after-action report, Marine General Holland Smith wrote, "The effect of the new ordnance on hardened defences exceeded all projections. Positions that would have exacted a terrible cost in marine lives had been neutralised before our landing craft touched the beach." This represents not just a tactical advantage, but a strategic revolution in amphibious operations. The strategic impact became increasingly clear as the Pacific campaign accelerated. General LeMay analysed mission reports from 20 subsequent napalm deployments across 3 island groups. The statistics were definitive. Pre-invasion bombardments using the new weapon reduced combat durations by an average of 62% compared to previous operations. The casualty projections for upcoming campaigns were revised dramatically downward. In Tokyo, military planners faced a strategic crisis. Field reports from multiple islands confirmed the same alarming development. Underground command centers previously considered secure were suddenly vulnerable. A confidential assessment prepared for Emperor Hirohito stated, "American incendiary weapons have achieved unprecedented penetration capability. Our fortification strategy across the Pacific defense perimeter requires immediate reassessment." The Japanese attempted adaptive countermeasures. Engineering units were ordered to increase bunker depths, add additional concrete layers, and create firebreak zones around critical installations. But the pace of American advance left little time for implementation. Construction materials were increasingly scarce as shipping lanes fell under Allied control. What had been a coherent defensive strategy was deteriorating into desperate improvisation. At Harvard, Professor Fieser continued refinement work. The latest formula, designated M69, demonstrated even more alarming capabilities during testing. It not only penetrated concrete but created a secondary reaction that consumed available oxygen within enclosed spaces. This asphyxiation effect extended the weapon's effectiveness beyond direct thermal damage. Structures that might partially withstand the heat became death traps through oxygen depletion. The production machinery of American industry continued its remarkable transformation. Plants that had manufactured household products in 1941 now produced thousands of tons of napalm weekly. The conversion had required retooling entire factories, retraining workforces, and creating specialized handling facilities. 3 years earlier, such a transformation would have seemed impossible. Now, it was routine. On the factory floor at Michigan Chemical, production supervisor Margaret Wilson maintained relentless quality control. She had lost a brother at Tarawa, one of the bloodiest pre-napalm landings. "Every canister we produce that meets specification brings someone else's brother home," she reminded her teams during inspections. The personal connection to the war effort was palpable throughout the production chain. Technical innovations continued at an accelerated pace. Engineers at Boeing developed specialized delivery systems for B-29 bombers that increased payload capacity by 15%. The M10 cluster adapter allowed a single aircraft to disperse napalm over precisely calculated patterns, maximizing coverage with minimal ordnance. The weaponization process that had begun in laboratory beakers was now a sophisticated aerial delivery system. Strategic planners developed increasingly refined targeting protocols. Intelligence analysts identified critical nodes in Japanese defensive networks, TATPCs, command bunkers, ammunition depots, communications centers. Each became a priority target for specialized napalm strikes. This surgical approach magnified the weapon's impact far beyond its physical destructive capacity. Entire defensive systems could be paralyzed by targeting their control centers. Colonel Paul Tibbets, training for what would become the Hiroshima mission, observed a napalm demonstration at Wendover Field. "The implications are staggering," he noted in his journal. "If conventional weapons can achieve this level of destructive penetration, we're rewriting the strategic playbook entirely." Even to officers aware of the Manhattan Project, napalm's capabilities seemed revolutionary. Japanese intelligence grew increasingly desperate to understand the new American weapon. Captured documents revealed fragmentary information, enough to confirm the weapon's chemical composition, but not its manufacturing process. Emergency directives ordered construction of deeper bunkers with specialized ventilation systems, but material shortages made widespread implementation impossible. The strategic advantage remained firmly American. Marine Corps leadership, historically conservative in embracing new technology, became napalm's strongest advocates. General Alexander Vandergrift, Marine Corps Commandant, wrote to the War Department, "This single development has potentially saved more Marine lives than any weapon since the introduction of the machine gun. Production must be maintained at all costs." His endorsement ensured continued priority status for the program. Operations planners began incorporating napalm into the preliminary stages of all Pacific Island assaults. Standard protocol evolved to include specialized strikes 72 hours before landings, followed by precision targeting of surviving positions 24 hours prior to Marine deployment. This systematic approach transformed the character of amphibious operations throughout the theater. The psychological impact on Japanese defenders was documented in captured diaries and interrogation reports. Lieutenant Kenji Hamada, captured on Saipan, described the effect. "The burning gel flowed through our ventilation system like liquid fire. Men who had withstood artillery barrages for days broke under this new terror. How do you maintain discipline when the very air ignites?" This psychological breakdown became as significant as the physical destruction. Admiral Nimitz reviewed the operational data with increasing confidence. Islands that military planners had projected would require months to secure were being taken in weeks. The casualty ratios shifted dramatically in American favor. The strategic calculus of the entire Pacific campaign transformed. Timetables for the advance toward Japan itself were cautiously accelerated. The weapon's effectiveness prompted urgent requests from other theaters. General Eisenhower's staff requested napalm deployment in Europe against hardened German bunkers along the Siegfried Line. The War Department temporarily declined, prioritizing Pacific operations where the impact on fortified island defenses was most critical. The European War was approaching its conclusion through conventional means. The Pacific required innovation. On Okinawa, Japanese General Mitsuru Ushijima monitored reports of napalm's effectiveness with growing alarm. His elaborate underground headquarters, previously considered impregnable, suddenly seemed vulnerable. He ordered emergency modifications, narrower entrance tunnels, filtered air systems, additional concrete thickness. Engineers worked around the clock, but supplies were limited, and time was running short. The 1st of April 1945. The American landing on Okinawa began with unprecedented preparatory bombardment. Specialized squadrons delivered over 1,000 tons of napalm against identified bunker networks in the 48 hours before Marines crossed the beaches. Reconnaissance photographs showed entire defensive complexes neutralized. Underground positions that had taken years to construct were compromised in hours. The impact on Japanese strategy became evident as the Okinawa campaign progressed. Defensive positions that intelligence had identified as primary strong points were abandoned before American forces reached them. Intercepted communications revealed commanders pulling back to secondary positions, unwilling to risk troops in bunkers now considered death traps. The psychological victory was as significant as the physical. At Pacific Fleet headquarters, intelligence officers tracked another, significant development. Japanese units began dispersing rather than concentrating in hardened positions. This forced adaptation made them more vulnerable to conventional artillery and small arms fire. The strategic effect, cascaded, EII, napalm eliminated hardened positions, forcing defenders into exposed deployments where traditional weapons became more effective. The production statistics told their own story. By May 1945, American factories produced 20,000 tons of napalm monthly, 40 times the production volume of just 6 months earlier. Supply officers faced a new challenge: distribution logistics rather than production shortages. Special shipping compartments were constructed on transport vessels. Dedicated storage facilities appeared at forward bases. The weapon had become a central element of American strategy. Marine Corps casualties on Okinawa, while still tragically high, fell significantly below pre-operation projections. Post-operation analysis by the War Department calculated that napalm strikes had reduced American casualties by approximately 30%, compared to projections based on previous island campaigns. The human impact was measured in thousands of lives saved. Professor Fieser visited a military hospital in Hawaii where he met Marines who had participated in the Okinawa landing. "You changed everything, sir," a sergeant from Iowa told him. "We hit that beach expecting another Tarawa. Instead, their bunkers were already burning." The meeting affected Fieser deeply. His laboratory work had translated directly into battlefield effect, bridging the gap between scientific theory and human consequence. The strategic implications extended to invasion planning for the Japanese home islands. Operation Downfall, the planned invasion of Japan itself, incorporated napalm as a central element. Targeting analysts identified over 2,000 hardened positions across Kyushu, the initial landing zone. Preliminary bombardment plans allocated 50,000 tons of napalm against these positions in the weeks before landing. The casualties this would prevent were calculated in the tens of thousands. Japanese military leaders received increasingly desperate reports from Okinawa. Their defensive doctrine, built around hardened positions that could withstand conventional bombardment, had been rendered obsolete. Emergency planning sessions in Tokyo considered radical alternatives: dispersal into mountain positions, civilian resistance networks, suicidal counterattacks. None offered a coherent response to the strategic vulnerability napalm had created. In American war production, the napalm program became a model of industrial efficiency. What had begun as a laboratory curiosity had evolved into a standardized manufacturing process employing thousands. Quality control systems ensured consistent performance. Distribution networks moved the finished product from factory to front line with increasing efficiency. The entire system represented American industrial capacity at its most effective, the 25th of May 1945. On a test range in Utah, The final refinement of the weapon demonstrated its full potential. The M74 napalm bomb, combining the latest chemical formulation with a precision delivery system, penetrated a replica of Japanese headquarters bunker design. The temperature recording devices inside registered 2,200 degrees before failing. The concrete didn't just crack, sections actually liquefied under the thermal assault. Military observers watched in stunned silence. The test results circulated through strategic planning offices with dramatic effect. General Marshall requested a comprehensive assessment of how this capability would affect invasion requirements for the Japanese home islands. The preliminary conclusions suggested the possibility of neutralizing major defensive networks before landings, potentially reducing the massive casualty projections that had haunted planning staff. On Okinawa, the battle continued, but its character had fundamentally changed. Japanese resistance remained fierce, but increasingly disorganized. The coordinated defense that had been expected from underground command bunkers fragmented into isolated pockets. American forces advanced more rapidly than expected, taking territory that planners had allocated weeks to secure. The napalm effect compounded itself through the campaign's duration. The strategic assessment became increasingly clear. Admiral Nimitz's planning staff calculated that the time required to secure the Japanese home islands might be reduced by months through systematic application of the new weapon against hardened defenses. The implications for the war's conclusion timeline were significant enough to alter diplomatic approaches and surrender terms discussions. In Japanese military circles, the strategic crisis deepened. Their entire defensive concept for the home islands centered on fortified positions that would exact an unbearable cost on invading forces. If those positions could be neutralized from the air, the strategy collapsed. Emergency discussions in Imperial headquarters considered increasingly desperate alternatives, including chemical weapons deployment and civilian suicide attacks. American production planning shifted toward the requirements for Operation Downfall. Estimated napalm requirements exceeded 100,000 tons for the initial phase alone. Chemical plants across the Midwest received priority material allocations. Rail transport schedules were revised to accommodate increased volume. The industrial mobilization demonstrated American logistics at their most impressive scale. The human dimension remained central. At training facilities in California, Marine units preparing for the invasion of Japan received briefings on how napalm strikes would affect their landing zones. Veterans of Okinawa described bunkers rendered inoperable, defensive positions abandoned before infantry contact. The psychological effect on troops preparing for what many expected to be a suicidal mission was profound. Hope emerged where fatalism had prevailed. Japanese military engineers worked desperately to develop countermeasures. Experimental bunker designs incorporated sacrificial outer layers, specialized ventilation systems, and thermal barriers. Limited testing showed marginal improvements in survivability, but nothing approaching immunity to the weapon's effects. The fundamental vulnerability remained. As one engineering report concluded, "We cannot prevent penetration, we can only delay it." American targeting became increasingly sophisticated. Photo reconnaissance aircraft mapped defensive networks in unprecedented detail. Analysis teams identified ventilation systems, entrance tunnels, and command centers within larger complexes. Each became a specific aim point for precision napalm delivery. The approach transformed area destruction into surgical precision, maximizing effect while minimizing ordnance requirements. The production workforce itself represented another American advantage. In factories across the Midwest, 3 shifts operated around the clock. Women comprised nearly 40% of this workforce, many having never worked in industrial settings before the war. Their precision and reliability became legendary. Defect rates in napalm production fell below 0.5%, an unprecedented quality level for wartime manufacturing. By June 1945, targeting plans for the Japanese home islands were complete. Every identified hardened position had been catalogued, assessed for vulnerability, and assigned specific napalm requirements. The scope was staggering. over 15,000 individual targets requiring coordinated strikes by hundreds of aircraft. The operational planning represented military logistics at its most complex and effective. The psychological impact extended to American political leadership. Secretary of War Henry Stimson, deeply concerned about the projected casualties of a conventional invasion, received briefings on napalm's effectiveness against Japanese defenses. The possibility of significantly reduced American casualties influenced discussions about alternative approaches to ending the war, including demonstration atomic strikes and modified surrender terms. The weapon's effectiveness created ethical discussions among military leadership. General George Marshall questioned whether such a destructive capability created new moral obligations in its application. The discussions acknowledged the weapon's terrible effects, while recognizing that its precision application against military targets potentially reduced overall casualties on both sides by shortening the war. In Hawaii, medical units prepared for the invasion casualties with revised projections. Hospital ships and field hospitals that had been planned based on Iwo Jima and Okinawa casualty rates cautiously reduced their estimates based on napalm's demonstrated effectiveness. Medical planners remained conservative in their adjustments, but the trend was clear. Fewer American wounded were expected because of the weapon's pre-invasion impact. The industrial achievement was remarkable in historical context. In 1939, the United States had no napalm production capacity. By mid-1945, production exceeded 20,000 tons monthly from a standing start. This 20-fold production increase in less than a year demonstrated American industrial capacity at its most responsive. The system that had begun with laboratory beakers now consumed trainloads of raw materials daily. July 1945. Final preparations for Operation Downfall continued. Napalm stockpiles at forward bases reached 60,000 tons, with monthly production continuing to increase. Specialized bomber groups trained exclusively in precision delivery techniques. Target folders for the first phase included over 5,000 hardened positions on Kyushu. The scale dwarfed all previous Pacific operations combined. On testing ranges in California, Marine units rehearsed assaults on napalm-treated fortifications. The training incorporated realistic timing, SAO, attacks occurring hours after incendiary bombardment. The tactical adjustments were significant. Units were taught to identify compromised bunkers by smoke patterns and structural damage. The integration of air-delivered fire support with ground tactical movement represented a new level of combined arms sophistication. The strategic advantage extended beyond the physical destruction. Japanese defensive planning was thrown into disarray. Traditional doctrine emphasized fixed defense at shorelines, trading space for American lives. That approach had been rendered obsolete. Emergency revisions considered mobile defense, inland concentration, even abandonment of shoreline positions entirely. The confusion itself represented a significant American advantage. What had begun as a chemistry experiment in a Harvard laboratory had evolved into a strategic weapon that reshaped Pacific warfare. The impossible problem, to neutralize reinforced bunkers without prohibitive infantry casualties, had found its solution not in brute force but in applied science. The teamwork between academic researchers, industrial engineers, and military planners represented American innovation at its most effective. The 6th of August 1945. The atomic bomb was dropped on Hiroshima, introducing an even more devastating weapon to the Pacific War. But military historians would later note that napalm had already transformed the strategic equation. Japanese defensive positions, the cornerstone of their strategy to make invasion prohibitively costly, had been rendered vulnerable months earlier. The path to surrender had multiple causes, not just atomic devastation. After Japan's surrender, assessment teams examined Japanese defensive preparations. What they found confirmed the weapon's impact. Bunkers that intelligence had identified as operational command centers had been abandoned. Desperate attempts to create napalm-resistant structures were evident. Additional concrete layers, narrowed entrances, filtered ventilation systems. none would have been effective against the final M74 formulation. The scientific team that had created napalm disbanded as quickly as it had formed. Professor Fieser returned to cancer research. Standard Oil engineers resumed petroleum development. The production facilities converted to peacetime manufacturing. But the knowledge remained. Chemical energy could be directed with precision against specific targets, a concept that would influence military technology for decades. The human impact was most significant. Marine Corps planners calculated that the invasion of Japan, had it proceeded, would have cost between 250,000 and 500,000 American casualties. Japanese civilian and military deaths would have numbered in the millions. The weapon that penetrated concrete at 2,000 degrees had helped prevent this catastrophic human cost by convincing Japanese leadership that their defensive strategy had collapsed. Veterans returning from the Pacific carried stories of how the weapon had changed combat reality. "We hit beaches expecting to die by the thousands," recalled Sergeant Thomas Ryan of the 3rd Marine Division. "Instead, we found their bunkers already destroyed. The weapon we never saw saved more of us than any other." The sentiment was echoed across veteran organizations and military assessments. In the immediate post-war period, the napalm story faded from public consciousness, overshadowed by atomic weapons and the emerging Cold War. But military historians and strategists continued to study its impact. The lesson was clear: scientific innovation properly applied could solve seemingly impossible tactical problems. The principle would influence military research and development for generations. The human story behind napalm's development represented American wartime cooperation at its most effective. Academic scientists, industrial engineers, military planners, and production workers, SCS, many of them women entering factories for the first time, had created and deployed a war-winning weapon in months rather than years. The achievement demonstrated what was possible when national purpose aligned with scientific innovation. Decades later, military historians would reassess napalm's strategic impact. While the atomic bombs that ended the war captured historical attention, the weapon that neutralized Japanese bunker networks had already rewritten the strategic equation. By rendering hardened defenses vulnerable, it had undermined the entire Japanese strategy of bleeding America into a negotiated peace through prohibitive casualties. The legacy was complex. Napalm would be used in later conflicts, sometimes controversially, but its original purpose, infide, penetrating hardened defenses that would otherwise require massive infantry assault, DRA, represented a targeted application that saved lives on both sides by hastening the war's end. The ethical calculus, while complicated, acknowledged that precision application against military targets potentially reduced overall casualties. The story of napalm's development and deployment illustrated a fundamental truth about modern warfare. The decisive advantage often comes not from superior numbers or conventional firepower, but from innovative solutions to specific tactical problems. The bunkers that Japanese generals had believed impregnable were defeated not by greater explosives, but by applied chemistry, reshape, an approach they never anticipated and could not counter. Up next, you've got two more standout stories right on your screen. If this one hit the mark, you won't want to pass these up. Just click and check them out. And don't forget to subscribe and turn on the notification bell so you don't miss any upload from us.